Alright, in this video I'll be talking about set operations. So, what do I mean by operation? Well, in numbers, the operations that we've seen are addition, subtraction, multiplication, division. We've all seen those. Those are all called binary operations because you start with two numbers, and from those two numbers you make a third. There are also, for numbers, a unary operation called opposite. The opposite of -3 is a +3, for instance. And another one, or for most numbers, called reciprocal. Reciprocal of 3 is 1/3. The only number that does not have a reciprocal is 0. But anyways, you can have binary operations and unary operations. I suppose you could have more, ternary or something, but for sets, we do have some binary and one unary operation to talk about. So the four things I'll talk about in this video are the union, the intersection, the complement, and the difference. And really the difference is not needed. It's just composed of other things. And we'll see that later. Okay, so for the union joins two sets together. So if I had the set 1, 2, 3, and then this U without a stem is the union sign, 2, 4, 6, then I just need to take everything in the first set or anything in the second set. And you notice I have a repeated 2, and it only shows up once in the set. That's because in sets, you just have members. You don't need to list something twice. 2 is a member. That's it. You don't put it down twice. Okay, and that was in roster notation or listing notation. You could, if you have a descriptive, notice I just said or, right? So you can just do that. Talk about it's the first or the second. Now there are other ways to talk about a union. For instance, I could say that the mammals, and I had to look this up online, a mammal is either, a mammal belongs to one of three types, It is placental, marsupial, or monotremata. So that's the, those mammals that bear the young in the usual way. For mammals, such as us humans do, marsupials have immature young, and then the monotremata lay eggs. So those are the three subclasses of mammals. But I haven't used the word or, I just said it belongs to one of the three. Yet, I'm saying that those three combined make the bigger set, the mammal. Okay, we could also have an intersection. And the intersection is what things are in common. So we've got between the set 1, 2, 3 and the set 2, 4, 6, what does it have in common? It has the 2 in common. So that's the intersection. That's an upside down union sign. If I did it with fruits and vegetables, then I have the word and is what usually gets used for an intersection. And in this case, it's the empty set. There's nothing that is both fruit and vegetable. You could also describe it, you'll sometimes see however, but, he isn't working yet. He has a lot of money. So he belongs to the class of people who are not working, and he also belongs to the class of people who have a lot of money. And so he's in the intersection. Okay. Now, for the unary, which is a complement, I need to start out with a universal set, because the unary will be everything that's not in the set. And, that was supposed to be 7, 9. So if we start out with the numbers 1 through 10, and by universal set, we're saying those are the numbers we're going to be talking about, then everything that's not in the set 7, 9 are 1 through 6, and then we do not list a 7, and then the 8, and then the 10. And so in set description, if we have primes, often we describe a complement with not. So the B prime is the not primes. Okay, so set difference is our last one. Set difference are the things that are in the first, but not in the second. So we remove from the first the intersection. So between 1, 2, 3, and again 2, 4, 6, the intersection was at 2. So that gets removed from the first set, leaving you only with the 1 and the 3. And if we remove all the vegetables from all the fruits, well, it doesn't make any difference. No fruits are vegetables. If we, now, here's one way to say it in English. If we start with a set of mammals and we remove from that the set of things that can fly, we have the non-flying mammals. Now, the first and the third example, I want to point something out. The 4 was in the second set. 4 is not listed here in the difference at all. Okay, a goldfinch is in the second set. Goldfinch is not listed here at all. So the set difference is a subset of the very first set. The first set with some things removed, possibly. But it really, nothing in the second set will be in the difference. Okay. Now, and as I pointed out here, I said before, the difference can be made from the others. A difference is the same thing as intersecting with the complement of the second set. Okay, so we've got several operations here. What happens if we see several of them to be done at once? What order do we do? We have an order of operations on numbers. We need an order of operations for sets, for set operations. So, just with the numbers, if you see parentheses, do the parentheses first. And if you have parentheses within parentheses, you do the innermost parentheses first, and then you work your way outwards. After you're done with all the parentheses, then you do complements. And after you're done with all the complements, then any unions, intersections, and differences that you see are done in a left to right order. Just like addition and subtraction. If you see 3 plus 4 minus 6, you do the addition first and then the minus. Because that's the way they were, the order that they were. Okay, that does it for set operations. In this video, I'll talk about set operations. You've seen operations in numbers. These are the familiar addition, subtraction, multiplication, and division. Those are actually called binary operations because you start with 2 numbers and you end up with another. We also have unary operation of opposite. The opposite of -3 is a +3. So you only start with 1 number to form a second. In set theory, in this video, I'll talk about 4 set operations. As you see listed there, the union, the intersection, the complement, and the difference. Now, I could get away with just using the first 3, and we'll see that in a later in the video. The union joins 2 things together, makes things bigger, usually. And so it's anything in the first thing or in the second. Could be one or the other. It could possibly be both. So notice the 1, 2, 3 is in the first set, and then I've got this U without stems. That's the symbol for a union sign. And the 1, 2, 3 is here in the answer. And the 2, 4, 6 is in the second set, and the 2 and the 4 and the 6 are here in the union. Now, the 2 was in both, but I've only listed it once. Okay, if you have a set description, you'll often see people use the word or. And you don't have to use the word or. There might be other ways to talk about. For instance, I might say that that the mammals are made up of 3 kinds: the placental mammals, the marsupials, and the monotremata mammals. Now, I haven't said or. I said it's made up of the 3 kinds. I actually used the word and. But I've conveyed the sense that those 3 subclasses joined together form the class of mammals. And so I am talking about a union. Intersection. intersection is what is in common. So in my 1, 2, 3 and my 2, 4, 6 example, the 2 is in both sets. So the 2 is in the intersection. The symbol for an intersection is an upside down union sign. So be careful to remember which direction goes with union, which direction goes with intersection. It's easy for a beginning student to get them confused. In set description, you usually see the word and because, to the best of my knowledge, there is nothing that is both a fruit and a vegetable. I'm saying that's the empty set. A plant biologist may disagree with me, but to my knowledge, that is the empty set. For a complement, you need a universal set. You need to set boundaries. I'm only talking about, in this case, this example, I'm only talking about the numbers 1 through 10, the integers 1 through 10. And my apologies, that was supposed to be a comma right there. But, okay, so A is the numbers 7 and 9. Okay, so I'm supposed to list 2 numbers there. A complement would be the things not in A. Complement is just done with a little, a little apostrophe after the set name. And so everything that's not in here, so the numbers 1 through 6 are not in A. There they are. The number 8 is not an A, and the number 10 is not an A. So I've listed everything not an A. Here I am again with a description, and you usually just say not. So if B is the primes, then B is not the primes. Difference. So difference removes the second set from the first. So here we have, with my 2 other examples, if I start with 1, 2, 3, and I remove from that 2, 4, 6, I find the thing that they have in common, the 2 is what they have in common, and I remove that from the first set. Now notice, the 4 and 6 here, that was in the second set, they aren't listed at all in the difference. Okay, so it's, the difference is always a subset of the first set, and you're removing the intersection, which is actually what I said right down here at the bottom. It's the things in the first set and not, because of the complement, not the second set. The difference is the things in the first set and not the second set. Okay, let's go back here. X is a fruit minus X is a vegetable are the things that are a fruit but not a vegetable. My apologies, not a vegetable. Now, to my knowledge, that just gets you back to the fruits. If you start with a set of mammals and you subtract the things that can fly, you get the non-flying mammals. So we can say it a different way than saying and not that. Okay, what if you have several operations to be done on sets? What order you do them in? We have a specified order for doing things with numbers and addition, subtraction. What's the order for operations? Well, just like with numbers, if you see parentheses, take care of the parentheses. If you see parentheses within parentheses, do the innermost first and work your way outwards. Then you're going to do a complement. After you take care of all the parentheses, after you take care of all the complements, then any remaining unions, intersections, or differences are done in a left to right order. Just like addition and subtraction is done in a left to right order. Well, that's it for the little video on operations.